So, good afternoon, everyone. My name is Fabien, Noyler, as the colleague said before. I'm notably in charge of the FABLAB in Dassault Systèmes headquarters in Vélizy, France. But I'm also working in a service which is dedicated to strategy marketing. So what does this mean for, let's say, the company? It means we are trying to build different type of projects, innovative ones, new ones, strange ones sometimes. And the idea of this is to, of course, make marketing, but being able from those projects to get some conclusions, results, statistics, to take strategic directions for the company. So everything we feed back to the top management is used somehow to take strategic decisions. As you can see in the title of the slide, you have Made in 3D. This is somehow a community that we launched about 3D printing. And the idea of this is absolutely to understand who we are talking to, what those people are interested in terms of 3D printing, what type of profile they have. Are they engineers, kids, or anyone else? And this is what we crunch as the data to take decisions. So I will mostly explain you what type of, let's say, big line conclusions we had from this activity. And especially myself, as being the person in charge of the FabLab in Vélizy, I will come back on those, let's say, conclusions we have right now about 3D printing. So first, a lot of people say 3D printing is a revolution. We absolutely agree with this, of course. And you just need to walk around there to understand that it is a revolution. Now the question is it a revolution for some topics, all topics, or for only specific niche areas? For example, at the beginning, the media, they were saying, okay guys, now with 3D printing, you have the danger of having some crazy people building some guns, okay? This is what we call bad buzz for us, because it's not pushing the technology in a good way. It's not, let's say, promoting 3D printing how it should be. And as you will see, our conclusions about FabLab management is somehow very different from this, but we absolutely agree this is a revolution. One point which is quite important is that at Dassault Systèmes, of course, we know the industry, but using and creating the FabLab, by creating the FabLab, the idea was to talk to different people, mostly people like you and me, your kids, or daughters, your parents, whatever. So the wide public. We know the companies, we know that they are doing rapid prototyping, so 3D printing for many of them since a few decades already. So somehow this is not new, this is not a revolution for them, they know what it is. But it's going to be new for the wide public, and it is new for the wide public somehow. So they were using some 3D data already, visual stuff, then making some simulation, finite element simulation, as you can see on the, it should be this way, where's the laser, anyway. And it was mainly to create functional objects. So for example, this one on the left, the idea was to check if it's fitting inside the system, if you can manage it properly, if you can remove it easily if you are a maintenance person. And this was done using some either very high-hand 3D printers or middle-hand 3D printers. But it was really decision-making objects, not toys, not repair spare parts, nothing like this. So our understanding of the revolution of 3D printing is mostly the fact that it can be compared to what happened with personal computing in the last 40 years. From the big computers, as you can see on the top left, with transistors with the size of my thumb, to the most recent mobile devices like iPads, iPods, all the rest, Samsungs, no, doesn't matter. We can make the parallel with 3D printing. Of course, as you can see there, it's mostly injections devices that I've put on the bottom left, but absolutely similar. You end up from a system that was only usable by big companies for cost reasons, for room reasons, to devices that are accessible by anyone. By anyone, I mean, for example, a big Christmas gift. Okay. It's not a product that you will buy every day still. The different contacts we had, of course, with the internal people, but also outside Fab Labs, made us understand, of course we had ideas about this before, but it made us understand that it's really important to go and to use exact geometries, exact CAD data. If you don't do this, it's going to be a dead end for plenty of reasons. When I'm saying using exact geometries, it's using geometries that does not produce polygonal results. Not millions of triangles or things like this. NURBS, for example. In this case, it's okay. Why so? It's because when you're using exact geometry, not only you can reuse the file for plenty of different kind of activities or simulations or reuse for 3D rendering, but you can also keep it in a very long term to be able to still manage your files in 10, 20, 30 years. Because if you create a polygonal result right now, polygonal data, what will happen in 30 years? Maybe it's not going to be big enough in terms of triangle, or, well, it will probably not fit your usage. And you will probably need to make 10 versions if you want to do rendering, if you want to do finite element analysis or whatever. So it's not adapted. But sadly, it's the way that a lot of Fab Labs are taking. So we would like to push people for using some ideal exact geometry. And I don't push for the Dassault Systèmes products, even though I'm from the company, but I think it's really an important point for Fab Labs. And to illustrate this, I've taken this small example. It's a video which was done through CATIA product. It's a well-known Dassault Systèmes software. But just keep in mind what I said before. Exact geometry that allows you to be that allows you to do some finite element analysis, some high quality rendering, all this with the same unique geometry. No need to create 10 versions. So you start from a motorbike concept with some kind of shaping and sketching. Then, of course, ability to change, iterate on materials, some basic rendering, and then you can go, of course, to higher resolutions, contextualizations of the product, start the mechanical design, iterate on it, do some ray tracing, real-time ray tracing on it. And then, of course, in the end, being able to 3D print it as well. So it's not a dead end. It's really multi-usage geometry. So I will stop now, but you understood the point I wanted to highlight. I will not spend a lot of time on this one, because I don't want to be the salesperson of Dassault Systèmes today, even though, again, I'm from the company. But what I want you to remember on this one is, again, to push on what I said before. The 12 industries that you can see on the right, they all use exact geometries, except in very, very niche applications they use software with NURBS, with exact geometries, no matter what they want to do. What we understood from the FabLab management in Vélizy, meeting people from inside the company, of course, but also from external people that are allowed to visit the FabLab, by the way, and use the systems that are available there, is that, of course, you can make, as you can see there all around, objects that were absolutely impossible to do before, either because they cannot be done with standard casting techniques, or just because they are so complex that small production is just out of reach for price of mold question or any other technical details. For example, you cannot mount it, you cannot dismount it. It's not meant for being produced with another technique than 3D printing. We also had a lot of visitors in the FabLab and in our communities that went for something new. And when I say something new, is geometries that are not common to industries, notably industrial companies, because it's based on natural shapes. You have different kind of examples there behind me, like the mushrooms. Somebody designed on the top right an amplifier for sound of the iPhone, a docking station, 3D printed, by the way. We also launched two design contests that led to different kind of creations like the ones you see there, mostly for jewelry, but not only for this, just for decoration objects for the house. And this is new. Before, you couldn't do this. Or you could do it, but with different kind of complexity procedures. What's also possible now, and this is also what was fed back by the people we meet in the FabLab, is that you can design with constraints, different kind of objects, being industrial ones, like the ones you see on the left, which were given to us by Thales company, French one as well. And the idea here is to optimize the shape of the structure for gaining some mass or improving some physical properties, for example. In the middle, you have optimization of cost by reducing the number of, the matter, minimizing the weight again, minimizing the thermomechanical constraints you would have on the welding parts. And you can see the result on the bottom. This was given to us by Arab company. And then on the right, you have something absolutely interesting, which is constrained by geometry or by physical properties, and notably gravity. And in this case, it's mostly a designer, Sylvain Lefebvre from EMEA, which is also a person absolutely expert in mathematical environments. And the idea here was to create some objects, like the horse, like the small monster, that were staying on their feet without the need for any support, without the need for any structure around. And this is also absolutely new. We discovered that a lot of people were interested in ultra-personalization, customization, we call it, like the small project that was launched by some of our colleagues. The idea in this case was to create some small figures for your kids, being able to modify the face of the figure, modify the shape of the mouth, modify the ears, the color, of course, and this is, of course, accessible through 3D printing. So this slide is somehow a summary of what I said. and especially a summary of the people we meet at the Fab Lab and the type of people, the type of talents we get in contact to and with. So statistically, you have a lot of people who come for repairing parts, broken parts. So for most of them, they need to use a 3D scanner to scan, then get the geometry, then print it to repair the part. Makers, so mostly engineers or good technicians who come with an interesting project, either for a present for their family or simply because they have a funny or geek idea. And we also launched a lot of competition that brought a lot of winners, of course, to each competition. And those winners created a lot of interesting results as the one we've seen before. For example, the amplifier for the iPhone and many others, like the slug shell that you saw before. On the bottom of the slide, you see as well the connection, and that's very important. I've put it in small on the bottom right, but I shouldn't have done like this. A connection between the community we created, the Made in 3D community that I've talked about, that I introduced at the beginning, and the Fab Lab we have in Vélizy. It's absolutely connected, and we wanted to have this for understanding what people were doing, what type of profile they have, and thus being able to get some conclusions. And this is one project that came out of this relation between the community and the Fab Lab we are managing. We have Mathieu and Romain. So this is Mathieu, is a professional in CATIA modeling. And we have Romain, who was a specialist in Arduino platform. So together they met in the community, by the way. They discovered that they had some complementary skills. And they decided to create from scratch, with their own geometry, their own model, a quadcopter drone. And this is the first flight we decided to make inside the office. So private version first flight, so it's approximately still. And then we showed this project to the majority of employees who had 5 minutes to spend with us, including our CEO. And that's how we made people aware that there were plenty of talents inside the company, of course also outside, that could be discovered by using such a community and such a Fab Lab. So revolution is in the audience, of course. Being new artists, being new engineers, or just new talents that have ideas that just possibly cannot create them on their own. So they meet people, they talk to people, and of course they create the project in the end. And those last two examples are to illustrate what artists are now doing with 3D printing. The first example is a project we led with a Black Dandy. It's a professional shoemaker in Paris. Let's say medium range quality. And is specialized in creating ladies' shoes, souliers as in French. And the concept of this project was to customize absolutely the shoe of the lady by starting with a scanning process to get the exact shape of the foot of the woman. Then by recreating the 3D model of the feet, being able to remodel automatically the shoe with the size, with the different parameters that are specific to the feet of the person. And then 3D print the shoe, of course, with adding some special finish, like leather, like colors, like plenty of things Black Dandy is specialized in. And the second project is the Love by Me project that you can see at the bottom of the slide. The idea of this one was to focus on jewelry. The concept is the following. You have two names, for example, yours and your girlfriend's or your man's. And so you put the two first name in small inputs on a web page, and it's automatically generating a jewel with the size of a 3D heart generated with your two first names. It's quite funny, and the result in silver is absolutely fantastic. So I don't have an example on me, but you can see it on the top right. And it's currently available, by the way, if you want to check. It's love.by.me. So that's the address of the community. If you want to share ideas, share projects, or just discuss with us about what we do in Dassault Systèmes related to 3D printing. I hope you enjoyed my presentation.